Okay, in this lesson we're going to look at building the perfect square. And this particular story talks about building quilt patterns. And you may or may not have seen quilts, but we're going to look at some of your math thought process to help us get through this. Okay, the problem is the quantity x plus 3 squared. And the final answer for that is x squared plus 6x plus 9. I would like you to take a moment and turn to the person next to you. I want you to look at the numbers in the original problem. I want you to look at the numbers in the answer and see if you can come up with some sort of pattern or answer to why that is the answer, where those numbers came from. Okay? Now let's continue back with the lesson. I'm going to show you with a diagram how they came up with these numbers and see if it goes along with what you were thinking. We have a square piece that's x by x because it's a square, which means if this side's x, this side's x, okay? And x times x is x squared. Then the person added 3 1-inch strips. So the length of this is 3. And over here, they added 3 1-inch strips. So this is also 3. What we find out is that they used a total of 1, 2, 3, 4, 5, 6. 6 strips that are 1 inch thick, but if you notice, the length of this line is x, which means this line also has to be x. So they're 1 inch by x, 1 inch by x, 1 inch by x, and there are 6 of them. So that is my 6x. Now to continue the pattern and make one whole square, one large square, I need to fill in this blank piece right here. So I'm going to fill it in with a square. Now, if you remember from a minute ago, we said that this was 3 inches because each one of these is an inch, and this is 3 inches. So if I want to find the area of this square, I would do 3 times 3, which is 9. So that is where we got the 6 and the 9. Let's look at another example. Okay? They ask you to make a sketch that goes along with the problem x plus 2, that quantity squared. Okay, so we have our x piece and we have our two 1-inch pieces that are 2 by x. Okay, so let's think this through. The area of this piece is going to be x times x, which is x squared. This rectangle here is 1 by x, so 1 times x is 1x. This is also 1 by x, so it's a 1x. This is 1 by x, so this is a 1x. This is 1 by x, so this is 1x. So when I combine like terms, 1, 2, 3, 4, I have 4 x's. So plus 4x. To make one whole square, I need to fill in this piece here, and I'm going to fill it in with a square. And the length of this from over here, because it's a rectangle, we know that this was 1, so this is also 1, and then another 1, making this a length of 2. This is also 2, so 2 by 2 is 4. Okay, let's look at the next one. This is a diagram of, they asked us to make a sketch of x plus 1, that quantity squared. Okay, and so, again, we have our x by x squared, so that's x squared. And then this time, this is a 1-inch piece. Sorry, my plus 1 is in the wrong place. This is a 1-inch piece. And this x, if this length is x, then so is this and so is this because they line up. Because they line up, they're the same length. So this is x. So 1 times x makes this 1x. This is 1 by x, so that makes this 1x. So I have 2 x's. So that gives me x squared for the square here. My 1x and my 1x is 2x. I need to fill in the missing space, and a nice little square would fit there. And that square is 1 by 1, and 1 times 1 is 1, and I am done. Okay, let's continue to look for some pattern. Okay, so in this one, we have an x and we have 4x. We have an x squared and the 4x, which means we have the x squared and we have 1, 2, 3, 4 inches. 1, 2, 3, 4 inches. So this little square would be 4 by 4, which is 16. Okay? All right? Now this one. Oh, wait a second. I made a goof. Let's look back. That doesn't work. I have a total of 4 x's, so let's rethink this. Okay, so I have an x, and I have 4 strips. So let's count 1, because I want to be even. 2, so I'm up to 3, 4. Okay. All right, so there's my model. Let's see. I have my x squared. Okay. I have my x, and then this is 2, so x plus 2, and I'm going to square it. So let's look. That's going to be x times x. That's x squared. I have 1, 2, 3, 4 strips, so 4x. When I fill in this space, it's going to be 2 by 2, which is 4. Okay, so we got to slow it down and think about this. I have my x squared. I have 6 strips, so 1, 2. I got to evenly distribute it. 3, 4, 5, 6. Okay, so this expression is my x and then 3 additional pieces. So my x and 3 additional pieces, and I do that pattern twice because it's a square, so squared. Okay, so when I find the area of each piece, I have an x squared. I have 1, 2, 3, 4, 5, 6x. And then to find this missing piece, it's 3 strips on top, 3 strips on the side, so 3 times 3 is 9. Okay, we're going to keep going. All right, this time I have 8 pieces. So I have my square. 1, 2, 3, 4, 5, 6, 7, 8. So when I look at this, I have my x, and then I have 4 strips. So x plus 4 squared. And so the area of this piece here is x by x, so x squared. 1, 2, 3, 4, 5, 6, 7, 8 strips. Okay, and then I need to fill in this piece. Well, this piece is going to be 4 by 4, which gives me 16. Last one. Okay, so I have 12 pieces. So I have my x squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When I divvied up the 12, 1, 2, 3, 4, 5, 6 in each direction. Okay, so the area of this square is going to be x squared. Remember, each one of these is 1 by x, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then we fill in this space. This is going to be a 6 by 6, so 36. Now, the drawing is a good way to figure this out, to visually see it. But you can see as this middle term gets larger and larger, it gets a little bit more tedious. So we want to start looking for patterns or maybe shortcuts to make it easier. Okay? So if x squared plus bx plus c represents the area of a square, what is the relationship between b and c? How to use b to find c? So I want you to think it through. Let's go back to the picture in a second. Here is my hint. I took the 6, for example, in problem B, and I evenly distributed it on 2 sides. So how did I come up with that number, and how does that help me come up with the last number? Take a moment and think it through. Okay, so hopefully you saw that we took whatever B was, we divided it by 2, and then we squared that number. Okay, let's see if that trick works. So half of 4 is 2, and 2 squared is 4. Half of 6 is 3, and 3 squared is 9. Half of 8 is 4, and 4 squared is 16. Half of 12 is 6, and 6 squared is 36. Will this strategy work if b is negative? Okay, well, negative is truly just a direction. Remember, we're thinking about building a shape like a rectangle. So if this was negative 6, this is really a length of 6, 6 units down. So my strategy would still work. So half of negative 6 would be negative 3. Remember, when you square a number, to put it in parentheses, okay, because I'm squaring the whole thing, the negative 3, and that would give me 9. So the strategy still works. You just got to be careful about signs, okay, because negative 3 times negative 3 will give me a positive 9. Will the strategy work if b is an odd number? What happens to c if b is an odd number? It will work. It's just going to be a slightly messy number, so it won't be as efficient for us. But let's look. Let's say we had an x squared plus 15, let's do a smaller number, plus 9x, okay? And then we're looking for c. So we're going to do 9 divided by 2, which you can either do 9 over 2, or you can turn it into a decimal, 4.5. And then to find c, remember, it's b divided by 2 squared. So now we're going to square this number. When I square this, I get 81 over 4. When I square 4.5, I can do it the long way. Let's see. Or let's do 4.5 times 4.5. We get 5, carry the 2, 22. And then we're going to placeholder, and 4 times 5 is 20, carry the 2, 18. We get 250, carry the 1. We get 20.25 because 2 numbers behind the decimal. So 20.25. It still works, it's just not as pretty. Okay, so my equation would be x squared plus 9x plus 81 over 4, or plus 20.25. Time for you to practice some more of these.